This is the Physical Activity Researcher Podcast, a podcast for researchers of sedentary behavior, physical activity, and sports. Join for a relaxed dialogue about research design, practicalities, and, well, anything related to research. Learn from your fellow researchers useful and relevant information that does not fit into formal content and limited space of scientific publications. And here is your host, researcher and entrepreneur, Olli Tikkanen.
Welcome, everyone. Before introducing our guest, I would like to ask for a small favor. It would be help a great deal if you could follow the podcast on Twitter and retweet an episode tweet if you see it relevant to your followers. And today, we have actually our first guest from the US. He's assistant teaching professor at Drexel University, Philadelphia. His research interests include the use of physical activity and exercise as a lifestyle therapy for the prevention, treatment, and control of chronic disease. He is publishing a book chapter related to evidence-based methodologies and dementia. Ladies and gentlemen, I am honored to introduce our guest, Professor Michael Bruneau. Welcome, Michael.
Welcome. Thank you so much. I really appreciate the invitation. Thanks for having me.
Yeah, great that you can take the time for this. So my first question will be, as you're from Philadelphia, have you ever happened to do a stair training in front of the Philadelphia Museum of Art?
Well, that's a funny one. I've been living in Philadelphia for about the last 3 full years, and I've never actually been able to run the stairs myself and have my own version of, Rocky Balboa running up the stairs and pumping my fist towards the sky, towards the city. But as I said, I think it's really important if you ever get a chance to come to Philadelphia. One of the must-see features is going to that Philadelphia Museum of Art. It is really a sight to see. The city's got really great history, and it's terrific for anybody that would like to come.
Yeah, I will definitely go there when I come. Yeah, and about your research, could you tell us a little bit more about your scientific background?
Sure, absolutely. So if we start way back at the beginning, so I went to my undergraduate education at Central Connecticut State University in New Britain, Connecticut. At the time, it was a state school, so it was close by to my friends and family. Had the opportunity to save a little bit of money and get a degree, but it didn't always start out that way. Interestingly enough, when I was in high school, I played football and was a track and field athlete, and really was interested in teaching psychology at the high school level. Well, little did I know that in order to really have a good job in that space and have something that would be attractive for employers, I was advised that maybe you should really major in history and specialize with a minor in psychology. So then you could teach both, right? And that would be more attractive to employers.
All right.
So I did that and changed my major a couple more times, went to exercise science at about my junior year at Central Connecticut State, and then very quickly learned that exercise physiology was really the space for me. Shortly thereafter, I parlayed that experience into an internship at the Hospital of Central Connecticut. It's their all-heart cardiac rehab program, and worked as a cardiovascular specialist and exercise physiologist. And then that rolled into my time at the University of Connecticut, where I did my master's degree. Worked under the tutelage of Dr. Linda Pescatello, who's very well known with exercise and hypertension. Then took about a year off, did some adjunct work back at Central, believe it or not, and realized that I love being in the classroom teaching, but I also love the research side of things. So I knew that I had to pursue a PhD. And so I went to Springfield College up in Western Massachusetts and got a PhD in exercise physiology and graduated in 2016. So still relatively new, early in my career. But that was sort of my lineage from where I started and how I got to where I am today academically.
Yeah, that's interesting that you wanted to teach psychology and you were advised to study history.
Yeah, I think it was more along the lines of just they were like, well, if you just teach psychology, that's going to be too specialized.
Yeah,
And so it's probably best if you study history, then you could teach a range of classes and in addition to psychology. So my advisors definitely had my best interest at heart at the time.
yeah. And about your studies, so you have been doing about physical activity and exercise interventions with different chronic diseases. So could you tell more about
Mhm.
those studies?
Yeah, so I'm really interested in cardiometabolic risk factors, right? So mostly the risk factors that comprise syndrome X or the metabolic syndrome.
Mm,
And so a lot of my studies really focus on cardiometabolic health. It all started way back. My first experience was working with Dr. Pescatello, and we were exploring the possibility for candidate genes that may be able to explain human health and performance traits.
mm,
And so we were part of this study called FAMOUS, and I may not have the acronym exactly right, but I believe it was the Functional Single Nucleotide Polymorphisms for Human Muscle Size and Strength Study.
yeah.
And so the idea behind FAMOUS was they were trying to identify candidate genes that could help explain some of the missing heritability or the variation in exercise responses, a la responders versus non-responders
Mm,
to resistance training. And so I got some experience doing that as a graduate level research assistant. And we started to look at the data and realize that a lot of the studies that have explored the candidate gene approach really didn't, they were all sort of trying to find the missing gene that would be the one that really explained either human performance or the one that would really explain responders or non-responders for health traits like blood pressure response to
mm,
exercise. So we looked at some of the data and the studies that were being published during the early 2000s and realized that a lot of them tended to be smaller with regard to sample size.
mm,
And they also had a number of other, not necessarily methodological flaws, but like, for example, correcting for multiple comparison testing with things like a Bonferroni correction factor. Um, some of them happened to be very subjective to sample selection bias, and so this really formed the master's thesis that I had conducted, which was a meta-analysis of all candidate genes that candidate gene studies that have been examining the blood pressure response to exercise. So we wanted to get a sense for what are the genes, what are the biological pathways to which these genes function that really dictates whether somebody will have a beneficial reduction in their blood pressure from exercise, or perhaps if identify genes where people may not get as much of a response.
mm. And when you said that strength training and non-responders and responders, did you mean that in relation to the blood pressure?
So the study had a number of different outcomes for it. So the primary aim of the study was to identify the genes that explain human muscle size and strength. But examples like blood pressure, Dr. Pescatello, I believe, has a 2006 paper that was published where she looked at the angiotensin converting enzyme insertion deletion polymorphism, or the ACE-DIP, and examined blood pressure response to exercise. And so the primary aim of FAMOUS was really to identify the genes that explain human muscle size and strength responses. But there were other outcomes such as physical activity, which a number of papers have been published from the FAMOUS data set with regards to genes that associate with higher or lower amounts of it's self-reported physical activity, but physical activity measurement nonetheless.
All right. And could you just explain the basics of how the blood pressure response is in relation to strength training and how it differs between different subgroups of people?
Yeah, so I think one of the things with regards to whether a blood pressure response will or will not happen is a lot of it is based off of what we call like the release of endothelial nitric oxide synthase, which has vasodilatory capacities for our vascular tree. So one of the ways that I explain it to my students is the further away you go from the heart, you go from more elastic to more muscular lined walls. And specifically at the level of the arterioles, we have a lot of smooth muscle in that particular capacity. And so one of the reasons why we see blood pressure actually increase during exercise, and as well as resistance exercise, where it's been known to surge very high, is because, right, we have an increase in cardiac output. So if you increase cardiac output, we're putting more blood into the system. And input into the system has not yet matched output from the system, right? So meaning not from the system, I mean blood that is making its way through the arterial distribution tree and getting down to the level of the capillary. And so input that is in the system is not being matched with output from the system. And so we see an increase in systolic blood pressure. However, one of the reasons why we don't see a tremendous increase in diastolic blood pressure is due to this concept of peripheral runoff. Are you familiar with that?
No, not really.
Okay. So the idea behind peripheral runoff is that by having a large increase in cardiac output as a result of an increased need for oxygen demand at our tissue levels, we can actually have redistribution of our channels. And sort of the way that blood flows through our tubes is very similar to how water flows through pipes of a resonance. So these little changes that exist within the level of our precapillary sphincters, we can bind catecholamines like epinephrine to a beta-2 adrenergic receptor, and this gives us some passive dilation. Basically, we open up a lot more of our vascular network. So that blood flow that has been increased at a more central level to the heart is now matched with a sufficient distribution network by the time it's feeding into the capillaries where it's going to exchange with our tissues. And so systolic blood pressure is often going to go up as a result of the exercise intervention itself, because we have an increase in heart rate and stroke volume and, of course, cardiac output. But by the time that blood that's ejected into the system gets to the level of the capillary, we've adjusted and opened up a lot more of our networks so that blood can be accommodated and can slowly sort of filter its way into the capillary network where we can have optimal exchange.
And then you were looking for genes explaining this. How is it different in different groups of people? This what you explained. Yeah.
Sure. So we've classified our genes in according to different biological pathways. So in the systematic review and meta-analysis that we had done, we classified them as either genes from the renin-angiotensin-aldosterone system, where a lot of genes have been explored previously. Some have gone through the sympathetic nervous system. Some have gone through the endothelial nitric oxide synthase pathway. Some have been inflammatory biomarkers, right? So they generally fall into those categories. But the one I really want to focus on with regards to blood pressure that I think is important is we did a paper in, I believe it was 2017, looking at physical activity levels and the angiotensin converting enzyme insertion deletion polymorphism, the same gene that I had talked about previously. And ACE has a really important role because it helps convert angiotensin 1 to angiotensin 2. And that conversion, when we have angiotensin 2, really becomes a potent vasoconstrictor. And that means higher blood pressure, right? Because we have higher resistance that is offered to the flow. And so having higher ACE levels has been shown to have very vasoconstrictive properties to our vessels, therefore increasing the resistance, since the size of the lumen in our vessels is now smaller compared to when it's in either a normal state or a dilated state, where we would see greater enhancements in flow. So essentially what's happening here is that people can either have 2 copies of the insertion polymorphism, they can have 2 copies of the deletion polymorphism, or they can have one insertion and one deletion. And what we found is that people who have two copies of the deletion polymorphism oftentimes will interact if in fact they are overweight. So in this sample from the famous study where we've looked at college-aged students, we found that there was about a 2.2 pound difference per year would be the calorie equivalent. So if you took 3,500 calories times 3,500 calories times 2.2 pounds, you would get the net number of calories that the person would, on average, with that genotype, consume or not expend in physical activity compared to people of the other two genotypes, which means that if we're talking about 2.2 pounds every single year over the course of an entire lifetime, that's a tremendous amount of weight that is going to be gained over the course of, say, from 18 to 55 or 65. This slow incremental weight every 4 or 5 years, you're gaining 10 pounds or so. And so we found that to be really important from a physical activity perspective. And we started to learn that that these genes don't only have one specific role to which they're assigned, right? We used to think that ACE was just, renin, angiotensin, aldosterone system, so with fluid balance and blood pressure control, but we also find that they have roles for other traits as well, like physical activity.
Right. So did I understand correct that the same gene is controlling our vasoconstriction, but somehow also related to the amount of physical activity that we perform?
Yeah, so I want to be clear and just state that candidate gene association studies are definitely association studies by nature, so we can't have cause and effect exactly. But these are what tends to happen with these with people who have these particular genotypes, is they tend to have lesser physical activity. Now, one of the things that we hypothesized in that paper was that people who have two copies of the DD genotype, the more unfavorable genotype, and who were overweight, is that we were trying to come up with some possible mechanisms for why that's the case. One of the cases was that we knew that there could be higher levels of of ACE activity. And so if we have greater constriction, right, then when we need to redistribute the cardiac output to the level of our muscles when we perform physical activity and exercise, if the tissues are already in a state of constriction, then we have that's problematic, because that means that we're not getting the same volume or the same level of oxygen extraction at that tissue site. And so exercise may be perceived by those who are performing it to be more difficult and less economical with regards to their effort compared to people who have other genotypes. So these types of studies need to be substantiated. But these were some of the things that we were going through trying to get a handle around our literature. And what we found, these are some of the mechanisms that came to mind, is that, well, if people have a more unfavorable genotype and they have more ACE expression, then that means that there's greater conversion to angiotensin 2, and then blood flow parameters are going to be altered. And that means that if we can't get the blood to the tissue, that might inadvertently affect the amount of oxygen that can be extracted from that tissue. And so exercise is more difficult. We may rely upon more anaerobic mechanisms earlier on in the exercise bout than we otherwise would in other genotypes.
Yeah, that makes sense. So basically they would feel local fatigue faster than the others and probably then not enjoy activity as much, and that would decrease their amount of physical activity.
Yeah, so we thought it was either going to be from the gene itself, that could be a possible mechanism for this association that we found. The other thing that we also understand is that as people gain weight, right, as they're gaining 2.2 pounds, roughly the calorie equivalent every single year, it's possible that as we gain weight, exercise, of course, becomes a little bit more difficult to perform. And so we have to also understand the possible effects that the added adipose tissue has, where we now have our body composition, which over time can change. And that too can make exercise perceived to be more difficult. There's thermoregulatory issues because with more adipose tissue, of course, we have a greater shell thickness. It's more of an insulative blanket. So tolerating heat becomes more of an issue. And if we can't release the heat from our tissues, that becomes problematic as well.
Okay, let's get back to that in a moment and hear a few words from our sponsors.
This podcast is sponsored by Fibion, a research device that has been shown to be valid in tracking sitting, standing, physical activity and energy expenditure. Furthermore, Fibion has been shown to be valid categorizing physical activity into light, moderate and vigorous intensity. In addition to scientific accuracy, Fibion provides automatically produced and easy-to-understand reports for research participants. Get scientific validation and learn more about Fibion at fibion.com/research.
How do you see, is there some practical applications from these findings that we could actually use somehow?
Well, I would probably say that, the average person, regardless of what your genes tell you, having a poor genotype doesn't necessarily, it's a predisposition, not a predestination. That's the sort of the key catchphrase that keeps coming up in this process is that, just because your genes may not necessarily be, you may not have the genotypes that are going to essentially put you in a place where you're going to be a responder or a non-responder. We have to remember there are several other genes. There's over 20,000 genes. There's over 3.1 billion nucleotides in the human genome. And we also have to account for the fact that there's also epigenetic factors, which can dictate the extent to which that gene is expressed or downregulated. And so, these are some of the questions that I think a lot of people in the field of exercise genomics are really starting to sink their teeth into. And I think it's very promising for the field moving forward, because when I first became involved with the candidate gene approach and exercise genomics back in probably 2009 or 2010, it was sort of, when Bill Clinton was president in 2000, towards the end of his presidency, the Human Genome Project thought that we were going to have all the answers to the gene approach. And so one of the things that's happened when I got involved in the candidate gene approach in 2010 or so was that we actually ended up having more questions than answers at that particular point in time. So the field was sort of in flux. I would probably say Dr. Pescatello has a better feel for where the exercise genomics field is going from here on out. Since that point, I've continued to publish a few papers with her with other candidate genes, and also apply the concept of physical activity and exercise from just blood pressure and genetic predictors of exercise responses to blood pressure, and moved on to other cardiometabolic things, such as working with an in-center dialysis program, working with exercise and hormonal regulation of appetite and hunger, right? Sort of as a root cause of that. And now more recently, where a lot of my newer work is being done is with exercise and cognitive impairment for older adults that live with dementia.
Yeah, I think the hormonal regulation of hunger would be interesting. Could you tell more about those studies?
Yeah. So when I was at Springfield College for my PhD, one of the things I really became interested in is selfishly is that, I've tended to struggle with weight throughout my life, and my weight's fluctuated a lot. And I always noticed that, if there was a way in which I can control my hunger, and that tends to be a really big symptom for people that struggle with weight, is there's, especially for bariatric populations, is the struggle with hunger is very, very difficult. And so I started looking into this during my PhD as I began to get a better sense for some of the endocrine factors that really dictate appetite and hunger. And one of the things that I realized is, first, the difference between hunger and appetite, operationally defined. So, hunger is probably best defined, the way that I operationally define it, as our true biological drive to eat, right? So if you think about need theory, right, we need to sleep, we need to eat. Your body will know when you are truly hungry, right? Biological drive to eat. You will do things to get that food to correct that sort of positive feedback loop that you have, where hunger just becomes the sensation of being hungry continues to compound itself until you eat. But the other thing that I think is also important is that appetite, differentially from hunger, really looks at the affective relationship that we have with food, right? Sort of the sense of smell that associates a meal or a particular food that we really enjoy, right? There's some type of either nostalgic feel that we have or relationship that we have to that food, which may not necessarily be true hunger, but it's a very desirable want that people have. And so I started saying, okay, well, what are some of the reasons that dictate hunger and appetite? So I started looking at appetite regulating hormones. And one of the things that I was interested in knowing is whether or not we can use exercise, right? We knew that exercise should be used to increase energy expenditure, and we should work with registered dietitians to decrease our energy intake, and that's going to help us with weight loss, right? Because we're going to create that caloric imbalance. But I was really interested in wondering, well, instead of having these as independent entities, can we create an interdependent environment where we can use energy expenditure to modify energy intake? And so I started doing, as part of my dissertation work, I recruited people from Western Massachusetts. And it was very clear criteria that we wanted to make sure that we compared people who were quote unquote normal or healthy weight versus people that were quote unquote clinically or obese, right? So they had to have a BMI over 30. We put them into a bod pod, and we wanted to make sure that they had their waist circumference. For men, it was over 102 centimeters. Women, it was over 88 centimeters. So they needed to have all three of these things that we were doing to make sure that they were definitely divergent groups. And we gave them three different conditions. And this model is actually based off of a model that I worked with Dr. Linda Pescatello on during my time at UConn. I liked the model, which was a repeated measures design. We randomly assigned people to either a seated control session for 40 minutes, a 40-minute aerobic exercise bout performed at light intensity, a 40-minute bout of exercise performed at moderate intensity, and a 40-minute bout of exercise performed at vigorous intensity. We did this based off of the heart rate reserve, particularly because we had found that folks who we put through our submaximal and maximal testing protocols sometimes would struggle to stay at a moderate to high intensity for a full 40 minutes, right? It's very difficult. So we use the VO2 reserve, which we can use it based off of heart rate, or we could do it off of VO2. But the good news is that it really doesn't matter if you use heart rate reserve or VO2 reserve, since heart rate and VO2 are 1-to-1 with each other. So we knew that when we prescribed these exercises at the reserve, we would not only be in alignment with the American College of Sports Medicine's exercise guidelines for what the evidence has shown to be light, moderate, or vigorous intensity, but we also took blood before and after control, before and after the light exercise, before and after the moderate, and before and after the vigorous. The novelty of that particular study was that we realized that some of the peptide hormones that are associated with appetite and hunger include things such as ghrelin, and you could think of ghrelin as your stomach growling, right? So ghrelin. We looked at leptin, okay, which is a satiety hormone that's released from your fat cells. We looked at insulin. Okay, we looked at insulin for this particular study. And there was a fourth. Oh, we looked at the enzyme which was recently developed for ghrelin, which stands for ghrelin-O-acyl transferase. Okay. And so what's really important is for ghrelin, it's important to realize that it can either exist in an acylated or a deacylated form. And that basically means that we have phosphorylation to the side chain of the molecule, specifically the serine side chain of the molecule. And so if we go ahead and have covalent modification, we phosphorylate ghrelin and we essentially turn it on, right? Like a light switch. We turn the enzyme on, and now it's capable of crossing the blood-brain barrier and binding to its differentiated receptor in the hypothalamus to ultimately induce hunger. So we looked at this enzyme called ghrelin-oacyl transferase. It's located in the level of the gut, specifically the submucosa of the stomach, where ghrelin is also co-secreted. So they're both released at the same time. And one of the things that we found was that ghrelin-oacyl transferase enzyme concentration in the blood was not different between obese populations and our normal weight population, which means that from a perspective of regulating appetite with the hormone ghrelin, that the enzyme that's required to activate it seemed to be similar and existed in both concentrations for both folks that were in quote unquote the normal group and quote unquote the obese group. So that was a really important finding, which means that, regardless of your body weight, you should be able to regulate appetite similarly. Of course, we saw that when we looked at leptin, that people who were in the obese group, they tended to have higher than normal leptin. But that's not necessarily surprising, right? Because leptin is one of those hormones that the more adipose tissue you have, the greater amount of leptin you'll release. So we expect it to have higher amounts of leptin. And so while this specific study didn't have data to inform the presence of leptin resistance, are you familiar with leptin resistance?
Not too well.
Okay. So if you think about what insulin resistance is for type 2 diabetes, right? We have something called leptin resistance for appetite and hunger. So the idea is that the problem may not necessarily be that people who are overweight or obese, right? That it may not be that they have excessively high levels of hunger hormone and that they're hungry all the time. It could actually be a problem where the receptors are either all occupied or the leptin cannot bind to its receptor in a way in which it's going to effectively uptake and provide physiological advantage to us. So essentially we can't turn hunger off, right? And so that it's a challenge with turning hunger off. And so I thought that this was a really important piece to the population. And the way I got interested in this to begin with was I said, okay, well, hypertension, right? What are some common things between hypertension? And I skipped over the work that I've done with dialysis work. But the common theme that exists for a lot of these health conditions is obesity. And so I said, well, I think that this would be an important thing, is that we know that to control obesity, it's multifactorial, right? I only could comment about my specific role as an exercise physiologist and how I think exercise can be beneficial for people in curbing your appetite and hormones. But there's a whole host of therapies that need to be integrated into what I consider to be an interdisciplinary model of care for obesity. This would involve work with people such as behavioral interventionists that know how to get people to actually do the activity and to understand the relationship that they may have with food. This is all beyond my pay grade here. And so they should be referred in work in collaboration with exercise physiologists. But I think exercise as a tool could be, to your listeners, understood to be a really helpful tool to suppress appetite and hunger for at least the short term. We'll give you an example. We know that in previous studies, if you use exercise to curb appetite, it may only last for, say, 30, 60, up to 90 minutes. At the best case scenario, maybe 2 hours. But if you exercise and you time the exercise at the right period of time, let's say you're a night eater, right? And maybe if you go and you exercise and you get that satiety-inducing effect from the exercise by having lower levels of ghrelin in your circulation, then you may be able to go home, hydrate, and go to sleep. We just prevented an overeating episode. And so I think it's really important. I can comment on this in my own life that I found to be really helpful. So I've been for the last year or so been training Brazilian Jiu-Jitsu.
Yeah.
And I find it's a very vigorous physical activity. And I have found that after I train Jiu-Jitsu, that when I go home, I'm usually not as hungry, right? Versus if I was in a sedentary state. And this sort of goes back to some of the work that John Blundell had done, where he looked at, I believe, workers, right? That worked, so factory workers that had different jobs, and ultimately found a J-shaped curve where the more sedentary you are, the more dysregulated energy intake and energy expenditure was. But the more active your job was, the more tightly regulated you generally consume the amount of calories that you expended.
Yeah.
So I was really interested in this process, and that was sort of the major motivation behind getting involved with that particular study.
Yeah, no, that's fascinating. I think there's some studies doing also setups that the participants are sitting the whole day, and then they can freely eat as much as they want. And then on another occasion, they are standing the whole day, and again, they can eat as they like. And basically, when they are sitting, they are eating too much compared to their energy expenditure.
Interesting.
And then on the third condition, they are sitting and they are given the right amount of food, and they are reporting that they are still hungry. So I think
Wow.
there's a link between sedentary behavior, that somehow the feeling of hunger doesn't work. I don't know too much about how is it like that, but I have seen the study, and it's quite fascinating.
Yeah. The other thing too is a lot of people, just because I provided the mechanism for the first study, I'll just kind of go through the idea of why we think the exercise has created this interdependent model where you can basically not be as hungry after exercise. And it's really right. We learn this in undergraduate exercise physiology courses, that if in fact you, when you exercise, we know that there's a drastic redistribution of blood flow, right? From what we call the splanchnic area or the core all the way to the muscles, which will dominate almost 80 to 85% of the blood flow of the cardiac output. Well, it takes time to get back to that, right? So if you are redistributing the blood from the gut where ghrelin is secreted from, and you're allocating it to the level of the muscle, the hypothesis that's been out there in the literature is that it's going to take a longer period of time for that ghrelin to get in the circulation, because it's getting a lesser percentage of the total blood volume, and the likelihood for it to bind to its receptor, specifically the growth hormone secretory receptor, is going to be delayed, or it's going to take longer for it to travel in the blood, get to the blood-brain barrier, pass it, bind to its receptor. And so that process of being delayed, that's the key, is that the basic concept of redistribution of blood flow takes where the gut peptide is typically going to root from, and it slows its process through the system. So, that's kind of a key thing. Of course, we have to understand that when you transition back to the resting state from exercise, that it's going to go back, right? So that's why I kind of think the idea of exercise timing could be a really important tool for people that struggle with weight. And so, I have to conduct additional studies to now, do exercise timing studies in order to identify if there are different surges and to further support these mechanisms and hypotheses that I think are explaining the results. But it's an exciting field that I'm really looking forward to.
Let's have a short break and hear a few words from our sponsor.
This podcast is sponsored by Fibion, a research device that has been shown to be valid in tracking sitting, standing, physical activity and energy expenditure. Get scientific validation and learn more about Fibion at fibion.com/research.
Yeah. Sounds interesting. So about the timing, how would you say that if you want to avoid eating before going to sleep, what would be the timing of the exercise session?
Well, we do have to keep in mind that I would say, usually 4 hours before you go to bed,
Mm,
right? So if you go to bed at 10 and you're exercising at like 6 or 6:30 or 7, that would be a good time, because by the time you're finished exercising, it's probably like 8:39, right?
mm,
Um, Come home, shower, maybe eat something small, hydrate, and just relax for a little bit and go to bed. We do have to be careful though, because there are some literature and people that report that if in fact you exercise too late, some people it becomes like a second wind for them and they can't fall asleep.
mm,
So you do have to be careful with regards to that time. You don't want to dial up your sympathetic nervous system too close to bed because you may have a difficult time falling asleep.
yeah.
So generally, I would probably say to really make sure that you have that, um, probably as little as 3 hours, 4 hour window would be a good time window to do that. Um, Taking into account, of course, that when you come home, you may be eating after 8 o'clock, and that might not be a good thing. Um, but particularly because you're going to go to sleep all night. But uh, generally speaking, if the goal is to have total caloric intake, I think that time frame is really a window where people can get some benefit from.
Yeah, that makes sense. And if I go back to that study, you said that you had 40 minutes of light physical activity, 40 minutes of
Mhm.
moderate, and 40 minutes of vigorous intensity activity. Was there some differences between these that you found?
Yeah. So, with regards to leptin, one of the things that we found was that um, the more vigorous the activity was, right, and the more calories that were expended as a result of the activity,
Yeah,
that generally gave us a little bit of a slight leptin surge, so a little bit higher leptin after the activity versus before.
yeah.
And so that's no surprise, is that we see this a lot of times in like cyclists. And although I can't recall the exact number, I want to say the number is between 1,200 and 1,400 calories. If you look at cyclists
Mm,
who, go out and they do like 4 or 5 hour bike rides. And once you hit this threshold, you can actually induce a leptin surge. Some people who are, um, for instance, triathletes or people that are runners, marathon runners, so forth, sometimes they're not hungry after they complete a race. And that is predominantly due to the fact that they have these leptin surges after intense bouts of physical activity and exercise. And so, similarly, with our population, we found that with more vigorous physical activities, that tended to give us a little bit of a leptin bump, which was good because we saw that post exercise, the ghrelin and the GOAT levels were suppressed. That was across both groups, and at the same time, we saw leptin increase after exercise. Unfortunately, the surges were higher for the folks who were of higher weight versus lower weight,
mm.
but the actual change between groups was not different. So that was encouraging to see. Um, so to the extent that we can with the data we've had, that's what I would say about that.
Yeah. So basically, if I recap, so if you do 4 or 5 hour bike ride, your leptin will surge and you don't feel hungry. Why do you think this has evolved for humans? Why would it be like this?
Hmm. I have to be honest with you. I'm not 100% sure of the rationale because I haven't traditionally examined studies with trained athletes. Most of the populations that I've been involved with have been people who are either living with risk factors for disease states, and then comparing them to healthy controls who may also be sedentary. So the exact mechanism for those studies, I can't necessarily comment on. But if I was to speculate on that, one of the things that I think is a result of it is that sort of energy expenditure thing that we talked about with that J-shaped curve,
Mm,
where the more vigorous the activity and the greater the energy expenditure, the better we seem to be in regulation of monitoring energy intake and energy outtake. And so I think due to the nature of those activities and the fact that energy expenditure is so high, that we become more tightly regulated, and the body sort of figures out what it really needs, as opposed to folks who are of lower activity status. They're not really, there's some level of dysregulation where intake and expenditure somehow they're just not in sync with one another.
Yeah, yeah. And I think I don't remember the study, so if somebody said to me this, but there was some speculation that if you compare light intensity activity to more vigorous, that when you do vigorous, actually your glucose reserves in the muscles are going down, and basically this is inducing hunger. But if you're doing light intensity activity, the same effect doesn't happen. So that light activity would be better for weight control. Do you see any logic in this?
Yeah, I definitely see logic in that. Certainly, I would also say that one of the things that I think about is implementation of the science. So, what is going to be feasible for folks to complete? That's what I think people ought to be doing. I don't think that's something new that I'm saying. I think that's been said for quite some time. But I think, I would rather have somebody exercise at a light intensity activity versus doing nothing. Sure, doing a little bit more would be beneficial for them, but if we progress them too quickly, the likelihood of attrition is high. So I would probably say that although, with higher levels of energy expenditure, it certainly makes sense that we would have leptin surges as a result of that and better regulation of energy intake and energy expenditure. I would say for certain populations, like those that may be struggling with weight, is that we have to start slow. And some of the best benefit that you can get is going from being sedentary, right, a quote unquote couch potato, to going and doing something. That's where the biggest benefit. And this comes back to, I believe it's John Wilder's law of initial values. Have you heard of it?
No, I haven't.
It's an oldie, but it's a goodie. John Wilder's law of initial values basically dictates that those who are the most, those who are at baseline and have not had any type of training have the most to gain, right?
Yeah,
they have the biggest ceiling versus people who are already trained. Their ceiling, they're already trained, so they already have a lot of benefits. So the magnitude of the change is probably not going to be as great, right? So that also applies for people when we're trying to get them active. If we go from the sedentary state to light physical activity state, right? That jump is likely to show some benefit. And that can be really motivating for folks if they can start snowballing that benefit, right? And it can become motivating where maybe they start to see some positive effects in their mood, or, maybe they lose a couple pounds in the first week or so. And they can then use that and parlay that into additional motivations to continue exercising. Of course, we have to understand that sometimes people that get involved with activities, that they sometimes are overly ambitious, right? And so I feel like a lot of people nowadays, when I work with some of my teammates who want to lose weight, is they'll say, I want to go on a very strict diet and I want to come and train 5 days a week. And I just say, right now I haven't seen you in 3 weeks. So maybe we should start by, let's just commit to doing 1 or 2 days per week for the next month. Right. And that seems like such a low goal that anybody would be able to do it. Right. And then slowly, after that behavior has been built in, start adding to it, right? As we start to see some changes and we've built that behavior into our system. So again, I'm not a behavioral interventionist. I'm an exercise interventionist.
Yeah.
But I think these are, from a practical standpoint for your listeners that may be interested in some of this, I think that's really important, is making sure that folks have a good understanding of how they're starting and being careful not to jump into it too quickly, because that can mean attrition.
Yeah, I fully agree. I think usually people are overly ambitious and they don't aim for sustainable behavior change. It's kind of easier to market for people something like crash diets,
Right.
when you should actually move just slowly and try to really change the habits, not to create the project in a way. Yeah, and if we leave the biochemistry side a little bit behind, I wanted to ask about your book chapter that you are writing about evidence-based methodologies and dementia.
Yeah. So first, a little bit of background in terms of how I went from, working with one clinical pop to the next clinical pop to the next clinical pop.
Mm,
One of the things that I think when someone's making a research line, specifically for anybody that maybe are in graduate school and they're trying to figure out, what am I going to be best at? What's the thing that I want to do my research in? And what's going to be sort of my mark and contribution to the field? Is really as we go back to the PICO formula, which, P stands for populations, I stands for interventions, C stands for controls or comparisons, and O stands for outcomes, right?
mm,
And, generally, as scientists, we really have to pick one of those three letters to be three of the four letters, the P, the I, or the O, has to really be our anchor.
mm,
And for me, it's always been clinically prescribed exercise programs. That sort of is the thing that is never going to change. But you can sort of pivot to different populations or related populations that are experiencing issues with the same thing to help fulfill gaps and needs that we have in the field. And we can also pivot and explore a number of possible outcomes that are relevant to those populations. So for me, one of the ways that I got involved with the use of physical activity and exercise for those that are living with dementia has been
mm.
with, we had a new dean that came to the College of Nursing and Health Professions last year, Dr. Laura Gitlin, and she's a sociologist who does a lot of really great work with older adults and making sure that, we want to try and let them age in place, live in the home. We don't want folks to have to go to long-term care facilities and rest homes. So the goal is to try and keep people living independently in the home for as long as possible. Well, she and I had the opportunity when she came on board to talk a little bit about, some of the risk factors and what are some of the key drivers towards people that live with, dementia.
Mm.
And one of the key things that came up was, do you have any idea what it was?
No, I don't.
Hypertension and physical
Yeah.
inactivity, right? And
Yeah.
so, in lower socioeconomic status. Okay. So I said, well, I think there might be something here. And so I started diving a little bit deeper into the literature, and Dr. Pescatello's lab from UConn actually did a systematic review and meta-analysis regarding current exercise guidelines for the World Health Organization
Yeah.
for older adults that live with dementia and specifically Alzheimer's disease, which is the most common form of dementia. And what we ultimately found was that there was some risk factors that associate with that. So I said, well, I talked to Dean Gitlin, and she had an internal funding mechanism. And I said, well, I think what would be really valuable is we need to be doing more resistance training type studies and for older adults that are living with cognitive impairment,
Mm,
because it's going to have a lot of benefit both from a functional standpoint of preserving some of the lean mass and hopefully improving the activities of daily living. But we can also examine what they do for the cardiovascular risk factors for the metabolic syndrome, right? So we can look at blood pressure, we can look at cholesterol, we can look at glucose, waist circumference,
mm,
BMI, and monitor changes there. We're also able to examine whether there are changes in cognitive assessment. So we use something called the Montreal Cognitive Assessment Scale,
mm,
which assesses multiple different domains of how we consider to be cognition, whether it's attention or verbal memory or tracing, doing a trace test. So what we ultimately came up with was, let's do a in-center. So we took an exercise program, not
mm.
holding it here at Drexel. We went out to a older care. We have PACE programs here in the States. So PACE stands for Program of All-Inclusive Care for the Elderly.
Yeah.
And so we formed a community collaboration with folks in the PACE program. And we told them a little bit about what exercise can do for their members at their PACE program, and they were really interested in working with us. So we've been out there for a little bit of time now, and what we do is we give them 3 days per week of seated, supervised resistance training exercise with TheraBands, and we're monitoring changes in risk factors for the metabolic syndrome, cognitive function with the Montreal Cognitive Assessment Scale, and most importantly, their quality of life. So we kind of got interested in our goal with this study that we're hopefully taking to the next level now is we want to identify exercise prescriptions for Alzheimer's disease and related dementias. If you look at the current ACSM guidelines, unfortunately, people that live with dementia are told, they're recommended to do the 150 minutes per week. That's everybody's recommended to do from the WHO.
Yeah.
So we're trying to identify, well, is that feasible? What's the optimal number of days per week? What should the intensity be? How long should the exercise session be? And what are the key modalities that they will enjoy? So we've integrated, I work with a creative arts therapist, Miss Natasha Goldstein-Levitas, and she does dance movement therapy that's integrated into our resistance training program. So it has a more of a therapeutic affective component to it. And then we also work with another colleague and great mentor of mine is Dr. Stella Volpe. She's here in the Department of Nutrition Sciences at Drexel. And she's really, really well known as a researcher for metabolic syndrome as well. Okay. So she helps us with sort of, she mentors me as a young faculty member, and she also has great expertise in sort of the nutritional component of our interventions. So that's sort of where we're at with regards to the field. We're trying to kind of figure out what are the boundaries of what an exercise prescription may look like for these folks. And our next steps would, of course, be looking at the biomarkers. So beyond just the risk factors for cardiovascular disease, we're also starting to think about, what does exercise do to some of the physiological changes that associate with Alzheimer's disease and other related dementias, right? So one hypothesis that I'm currently in the process of trying to figure out and develop is we know that exercise, we have the enzyme creatine kinase, right? So if you have creatine kinase, excuse me for this second. So
Yeah, no
we
problem.
have one second. There we go. Sorry about that.
No
So
worries.
we have creatine kinase can, of course, it's really important at the level of the muscle, right? And so that enzyme can exist in a multiple of different isoforms. One is level of the muscle, one is the level of the heart, and there's also one called creatine kinase BB in the level of the brain. And so there hasn't been a tremendous amount of work done with creatine kinase BB, which relates to the brain. So I'd be interested in seeing if exercise can have a positive benefit to that enzyme for people that are living with cognitive impairment, specifically Alzheimer's disease and related dementias. And the reason why I bring that up is because we know that there's been associations between long-term cholesterol use and Alzheimer's disease, right? So one of the things that I think about is, well, what's a side effect of long-term, or what's a side effect of cholesterol medication? Sometimes it's fibromyalgia, elevated CK levels. And so is it possible that some of what we see in the skeletal muscle as being elevated with cholesterol meds, is there a possible association where maybe we can also have elevated CK BB levels within the brain, and maybe certain cholesterol medications may be interacting with our physiology in a way where we're producing cognitive impairment as a result of it? And so I'm interested really to first, phase one of my work with Alzheimer's disease and related dementias is right now to finish our protocol now, get some preliminary data on that, and then refine and build out what an exercise prescription really looks like, what's evidence-based, so we can identify what the optimal number of days, intensity, time, progression, etc., is for this clustered group of Alzheimer's disease in related dementias. And then hopefully additional studies will allow us to identify if there's differences in how we prescribe exercise for people with vascular dementia versus mild cognitive impairment versus true Alzheimer's disease versus Lewy bodies, so on and so forth. And then get into some of the mechanisms. I think that's sort of the field has a lot of promise. And so folks that are listening that really are interested in that, I think it's a great opportunity that is going to be urgently needed for the future and the present. Because in 2050, dementia rates are expected to double by 2050. So it's going to be a very urgent health problem that we have to address.
Yeah, and this all will be covered in your book chapter. Do I understand correct?
Yeah. So we're going to cover. So I want to be clear. The book chapter actually is going to be led by Dr. Laura Gitlin. So the dean I told you about, she and I are going to be collaborating together on this, and so she's going to provide a lot of the evidence-based materials that are surrounded around the chapter. I've been invited as a co-author to work with her. And my specific role is going to be targeting, physical activity and other lifestyle interventions that can be helpful for people that are living with dementia.
Yeah. All right. Good luck with the book. When do you expect the book to be out?
That's a good question. I know we're still working on a couple of the chapter. We're still working on the writing now, but hopefully we'll have that submitted by the end of the year. And I believe maybe by May of next year, it will be perhaps in press or at least during review. So hopefully we'll be making some changes to that based off what the editor wants.
Yeah. And we've been talking quite a bit about the studies you have done. Let's go a little bit to the future. Where do you hope to see yourself in 10 years academically?
10 years academically. Wow. Well, let's see. I'm still pretty young. So I'm 32 years of age. And so, what I would hope is that by the time I'm 42, I have the opportunity to, number one, still be in very good health and mind and sound, and, still be able to provide quality education to my students here at Drexel. And I really hope that, within 10 years that we can start to really have these evidence-based exercise recommendations become something that's adopted by the American College of Sports Medicine. I want them this population to be served in the guidelines. And so my hope is that we'll have completed studies and got some funding to support these studies such that we have sufficient evidence with multiple studies and multiple lines of research that support them, and that we can start to implement. That's the other thing I really want to focus on is not only conduct the studies, but I want to also work with implementation research and figure out, great, we have this study, but on average, most research studies that are conducted, they take 17 to 20 years to actually be implemented into the real world setting. And so I want to, focus my work on how to take the findings that are learned and how do we actually get PACE programs to, create the infrastructure and see the value across the country and the world to start providing these programs for folks, because conducting the studies is one thing, but implementation is a whole different thing. And so learning the process of sort of what's the approach, what's the best practices for approaching and adopting these types of things is something else that I'm interested in. So conduct the studies, and I would say work on implementing them both into the guidelines that exercise practitioners can use when they're working with folks, and also work in terms of how we implement these interventions either in the home or into PACE programs where people who need them can get the benefit from them.
Yeah. It's been very interesting discussions. I have learned quite a bit about biochemistry, and if people want to follow your studies, are you active on ResearchGate, Twitter? How do they find best you?
Yeah, I would probably say the best way to find me, I am on ResearchGate. I think we connected on LinkedIn, so I'm on LinkedIn. You can find me there. My Twitter handle is at my last name, so it's Bruneau, Bruneau, Mill, so MI for Michael and L for middle initial. That's actually the same domain that I've used for since I was way back at Central Connecticut State for my login. So I kept it consistent over the years. And if folks want to get a hold of me, they can also email me at mlb425@drexel.edu anytime. I'm glad to talk or provide folks with resources that they may find helpful.
Yeah. It's been a pleasure. Thank you for taking the time to be the guest in this podcast.
Likewise, thank you so much for having me on. I hope it fit the bill and is helpful for folks who are listening. Thanks so much. I really appreciate it.
This podcast is sponsored by Fibion. Get scientific validation and learn more about Fibion at fibion.com/research. The Physical Activity Researcher podcast has created an activity tracker purchase guide for researchers. Get your free copy from the link in the podcast description.
Thank you for listening to the Physical Activity Researcher podcast.